Dear students, I Prakash Birla, Assistant Professor, Textile Technology Department, MLU Textile and Engineering College, Bhilwara. In today's my video lecture, I will discuss about some brief idea about the production processes of polyester fiber. In the polyester production or fiber production or polymer production, a high molecular weight PET is an essential prerequisite for the fiber formation. So therefore, there are the two popular routes you can say here. The polyethylene terephthalate can be produced by two routes, and each route consists of a two-step esterification process. In the route first, that is, you can say the terephthalic acid route, but the purified terephthalic acid is the prerequisite for this route. In this route, the terephthalic acid react with the monoethylene glycol, and in presence of some catalyst and suitable temperature pressure conditions, it can convert into an intermediate product, that is diglycol terephthalate. Means the two ethylene glycol molecules by condensation reaction join, or you can say the add on the both side of the terephthalic acid by replacing the H atom and get converted into the diglycol terephthalate, and water is liberated during this reaction. In the another route, and in this route, the DMT, dimethyl terephthalate, it's an ester derivative which react with the monoethylene glycol and get converted into in the first step of the reaction, get converted into the diglycol terephthalate, that is DZT. And during this condensation reaction, the methanol is liberated. Means the dimethyl terephthalate, and if we compare with the terephthalic acid, in the chemical structure you can see the difference. The methyl groups are attached and make an ester. So that's why the route 2 is you can say the ester interchange reaction, or you can say the trans-esterification reaction, and first route is termed as direct esterification route. By both the route, the next step of the polymerization is the intermediate product DZT is subjected to the polycondensation reaction, and that get converted into the final PET polymer with a high molecular weight, approximately for the fiber grade polymers. Here it is, the N is about 200 to 300, and about approximately the molecular weight average is about 22 to 22,000 is the most favorable. And during this, the excess amount of ethylene glycol which is taken in the start of the reaction get separated and collect separately and transfer to the recycling. And here the intermediate, yes, in the both of the methods, the intermediate DZT formation is, you can say why it is formed, or we can say this DZT formation leads to the number of advantages as compared with a direct mixture of the monomers subjected to the polymerization reaction. Means the terephthalic acid and monoethylene glycol, or DMT react with the monoethylene glycol, they generally do not directly subjected to the polymerization. Even it is better to go for the intermediate DZT formation, and this DZT formation leads to many advantages, and you can see here these are some list of advantages. The PC process, means the polycondensation process, is applied to a uniform, chemically pure monomeric starting material, that is the DZT. Means the here the monomeric, or you can say there is no comonomer, only a homomonomer, you can say homo starting material, single reactant is there. Another advantage, the wider choice of catalyst for this reaction, fewer side reactions, higher speed of reaction, good color of polyester, better thermal stability of the melt, better dryability. These are some advantages by using the two-step polymerization process, or we can say the intermediate DZT formation leads to these number of advantages. Here you can see the process via the DMT route. First, we can say in this diagram, the line diagram or the flow chart for the production of polyester using the DMT as a starting material. Yes, in this diagram, the DMT and MEG is taken in a particular ratio, say 1010 kilogram and 630 kilogram in the start to manufacture the 1 ton of the final polyester fiber, and the catalyst used both are fed to the trans-esterification reactor first, where the reaction is carried out at 230 degrees centigrade and methanol is liberated, and intermediate product monomer DZT is formed. And here with this DZT 50 kilogram of catalyst is present, and this DZT leads transfer to the next vessel where the final polymerization is takes place. And here initially low vacuum, then high vacuum is applied, and during this the excess amount of EZ is recovered and go for the recycled, and this reaction is carried out at 260 to 300 degrees centigrade. Then the polymer melt is transferred to the extruder, or you can say the extruded in the form of ribbon. This is solidified with the help of a cold water spray in the water bath. And you can see for the production of 1 ton of the polyester fiber, 1 lakh kilogram water is used, and this 1 lakh kilogram water go for the effluent treatment plant, ETP plant, for again recycling, purification and recycling. Then solidified ribbon is cut into chips. These chips are dried to remove the moisture, and again go for the melting and filtered, and melt spinning is carried out. And then these are the basic post spinning operations, maybe crimping, drying, cutting, or draw twisting for the filament yarns, and the spin finish is one of the operation is carried out during this post spinning. And during for the production of 1000 kilogram, here 100 kilogram of mechanical or spinning and mechanical losses may occurs. Okay, thank you.